What's up, everybody? I am not a software engineer, but today we're going to go ahead and implement some of the core functionality of poker in Python and Pygame. Let's go ahead and get into it. So, as you can see, this is my GitHub repo, and on my GitHub repo, I have my kind of boilerplate Pygame project repo that I have essentially created a new project based on. This is a public template you can use as well, or you can modify it yourself. But I basically have that on my local system, and you can see VS Code right here. So I can go ahead and let's see if I can increase the font a little bit. There we go. And yeah, we're going to go ahead and start walking through the setup for the poker game. So first things first, the way that I'm going to set this up is basically so that there are two players. One is player one and one is player two. They're on the left and the right hand side of the screen. And basically each of them will get dealt two cards. It will start with player one, then it will deal to player two, then player one again, and player two again, and then it will deal the flop. And we're going to use a poker hand ranking algorithm to basically assess who won the game. And that functionality right there is enough for us to have the building blocks for a full-fledged poker game down the line. So that is what we will do in this video. And so the first things first, basically what I want to do is create a couple of files that we will be using to build out our game. And one of those is going to be hand.py. Another one of those is going to be cards.py. And I believe that should be it for now. And what I'd like to do is go back over to main.py and make a few edits. First of all, we do need to import everything from those files, and there's nothing in them yet, of course, but we can do a from hand import asterisk and from cards import asterisk. And if you're like me and a bit OCD, we can actually put that in alphabetical order. And I believe that should be good. So there are a couple things that we need to modify here. We're actually going to get rid of self.delta time. We do not need it just yet. And I'm going to do a self.hand equals hand. And of course, nothing will happen just yet until we fill that stuff out. But we can go ahead and continue. So what I would like to do is generate a new hand every time I do a mouse click. So we're going to have a new event that we're looking at in Pygame, and if you have done any Pygame tutorials before, you should be used to this. Essentially, we're going to look for a new event type. If event.type equals pygame.mouse button down, then what we're going to do is make sure it's the left button, which is just event.button number one, and then finally we will say mouse down equals true. And then we can go down to another event and do another if statement. If event.type equals pygame.mouse button up. Then we will if event.button equals 1. And I will then say mouse down equals false in the event that if mouse down equals true. Let's go back to home here, and finally I will just create a new hand by running self.hand equals hand. Okay, so that means every time we click down and then back up again, we're going to generate a new hand. There are some issues with this, of course, and that is that you could essentially just deal a zillion hands over and over and over again. So there will be some guardrails around this in the future, but for now, this is just fine. So we're also going to go down here and we're going to make sure that we fill our screen with a background color that resembles a poker table. So I do need to actually rearrange this a tiny bit, put our update right here, and then I'm going to have a self.screen.fill BG color. And then we're going to update our hand. So self.hand.update. And that should be it for our main.py. I think this is actually done completely. Now, of course, we need to start filling out hand and BG color. So these are some of the things that I have in settings. And so what I wanted to do is just kind of go over what I have in settings. I do not want to kind of code this out line by line because it is a little difficult and unnecessary to do that. So I'm just going to paste that in. So you can see the title of our game is going to be Poker Hands. Our FPS is going to be 120. Of course, we're going to use 1920 by 1080 or 1080p as our resolution. Our background color is going to be Poker Table Green. And I have a game font that I believe I've used this in previous videos, which is pixelatedDisplay.ttf. Link for that is in the description of the video. And then we also have a game audio directory of just audio. So there are a couple other things here. This is basically the coordinates of the first card for player 1. This is the coordinates for the second card of player 1. And conversely, this is for player 2. Now, this is not the greatest design in the world because eventually we're going to have 9 or 10 players in our full-fledged poker game. But for right now, this is fine. We're just going to hard code the positions where the cards will actually be rendered. Then, of course, we have our value dictionary. So going back to poker, basically you have your 10, your jack, your queen, your king, and your ace, right? And those are valued above kind of these 2 through 9 values. I could just use 10 here, but then that would basically make 2 characters as the key, and I would prefer to keep them all at 1 character. So I'm just going to use a T for 10 and then have that map to the value 10, as you can see here. All right, so let's go ahead and start working on the hand class, right? That is kind of the important thing to do here because we are calling that immediately from within main.py, and if I actually ran this, it would just fail. So I'm going to go ahead and import a few things here, and that's going to be itertools, OS, Pygame, and random. I'm also going to import everything from cards, although there's nothing in there just yet. So from cards, import asterisk, and then from settings, import asterisk as well. And then I'm going to go ahead and put a section here for audio, placeholder. And I'm going to load a bunch of stuff there, but I'm going to put audio in at the very end so it's not annoying while we're actually developing and running this thing over and over and over again. But yeah, so we're then going to create our class hand. And I will have my init function, def init, which of course takes self. And for right now, I'm just going to put pass. And then for our def update, I'm going to put as pass as well. So I just want to see if this will run in its current state. And it does. So we have our very basic poker table, which is poker table green. And I can just quit that. So, in a poker hand, there's several things that we want to do. One is that we want to actually deal cards, right? And so we have our card images, which we will be using shortly. But I am going to need to draw those to a display surface. So self.display surface is going to be equal to pygame.display.get surface. We also need to have a winner, right? That's kind of the whole point here, is to just deal some cards and figure out who has the better hand using a hand ranking algorithm. So I'm going to have a self.winner set to none. I'm then going to have a font so I can print the winner to the screen. Self.font will be equal to pygame.font.font, game font, and then we will use font size of 120. I then would like to randomly rotate the text of the winner so that it's not like the same text that's drawn every single time. It'll look a little bit more interesting. So self.win rotation angle will be set to random.uniform. And then I'm going to have a kind of a range of -10 and 10. Then I'm going to have 2 players. So self.p1 will be equal to player. And self.p2 will be equal to player. We don't have a player class just yet, but we will shortly. Self.flop also is a class or an instantiation of a class that does not exist yet. Self.player list will be equal to a list of self.p1 and self.p2. We will be iterating through this list quite frequently. Then I'm also going to have a dealer. Self.dealer will be equal to the dealer class. And then that is going to take in the 2 players in the form of the list, self.player list and self.flop. So the dealer will then know how many players are in the hand, and then will also know that there is a flop that does need cards basically dealt to as well, right? So kind of those middle 3 cards in poker that do not belong to each of the players, but they can actually use to generate a hand will be part of the flop. So in our update function, basically what we're going to want to do is called the dealer's update very frequently, because the dealer is going to be doing, obviously the dealing of the cards, determining the winner, and yada, yada, yada. So we're going to go ahead and call self.dealer.update. And then we're going to have render cards, because we're actually going to draw the cards to the screen. Self.render cards. And then we also want to render the winner. Self.render winner. Okay, so you can see a number of functions that need to be created that don't actually exist just yet. So I'm going to start with render cards. Def render cards. It's going to take in self, and we'll just pass for now. But I'm going to put, actually I'm going to put a comment, draw cards at current positions, and then we'll just pass. Then I also want to do the same for render winner. And then I will basically say set the text and color based on the winner and print to screen. And then, of course, I'll just pass that for now. And so we need to start worrying about our dealer, because honestly, this is the most important class in the entire game. And that is basically where everything that occurs in the game is going to be by the way of the dealer. So class dealer, we'll have an init function, def init. And that is going to take in self, players, and flop, as you can see here. Those are our input parameters. And so there's going to be a whole lot of variables that we have in our init function, which may or may not be best practice, but in any case it does work for this particular example. The first one is going to be determined winner, self.determined winner, and that's going to be set to none, which means that there is currently no winner of the game. We will use that for a variety of things, but mostly to render the winner, right? Then we're going to have our self.players list is just going to be the input parameter players, and then we will have self.num players equal to the length of players. We're then going to get the current player index, and that's just going to be 0. Self.current player index will be 0. We're going to use that for some basic logic on where the card should actually go, depending on which index we're at. We're also going to do the same thing for the flop, current flop index, and that will be set to 0. Then we're going to have a self.printed flop set to false, which basically means we either A, did or did not print the flop. And we're going to use that to actually print the data to the console, right? Because it's kind of interesting to get the data of each hand in the console, and we'll want to make sure that our visual representation lines up with that. Then we're going to get a deck, right? And this is actually very important as well, because a deck is essentially 52 cards, and it's 4 suits, and then that's going to be 4 times our number of cards, which gives us 52. And so not only do we want to get that, but we also want to shuffle that. So we're going to do a self.deck equals self.generate deck, which is a function that we do need to create. And then we also want a random.shuffle self.deck, because obviously you would want to shuffle the deck in between each hand. You may as well do that when you initialize the dealer class. Then we will have a self.animating card set to none, which means that there is currently no animating card. We're going to have a can deal boolean, self.can deal, and that will be set to true. Then we also want to make sure we can deal the flop, so self.can deal flop will be false, because we cannot deal the flop until we deal to the players first. We would also like a few time-based variables, and one of those is going to be self.last dealt card time. That will be set to none at first, because we have not dealt any cards at first. And the second will be self.last dealt flop time, also set to none at first. We would like to keep track of how many cards we have dealt thus far, so self.dealt cards will be equal to 0 at first, and then our flop will be equal to the flop input parameter that you can see here. And finally, we're going to have some audio stuff here. Self.audio channel will be equal to 0. And so when the dealer deals cards, we want to make sure that we're not playing wave files to the same audio channel, because then it can get cluttered and yada, yada, yada. So we're basically going to play a sound to a different audio channel each time we play a sound. So we do need an update function, and I can go ahead and start creating that at first. The update function is going to be quite interesting here, because we're going to look to see Basically, if we've dealt enough cards to deal the flop. We also need to see if we should be animating a card as we are dealing it or just after we dealt the card. We need to update our number of dealt cards and a number of other things. So I'm going to go ahead and start building out the update function, def update. And yeah, so we want to get the number of dealt cards. And again, we set that to 0 to start, but I would like to get an update every single time this update runs, which is basically every frame, as you can see here. Every time hand updates, we also want to update the dealer. And so I can basically run our function that does not exist just yet, self.dealt cards equals self.update dealt card count. And this is a fairly easy function, but we'll get to that here in a moment. I also want to check my cooldowns, self.cooldowns. And again, we're going to kind of be basing that on these variables here. So we'll have to get values for those as the program runs. So in my update function, what I would like to do is check to see if self.dealt cards is less than the number of players, right, which is going to be 2 players in this case, times 2. And if that is the case, then I'm going to go ahead and deal a card. So I need a function for that, and that's going to be deal whole cards. The first 2 cards that a player gets in a game of poker are called whole cards. Self.deal whole cards. And that will be, of course, set to none, or rather pass for quite a bit until we build out the rest of our logic. But we're also going to check to see if self.animating card is set to something other than none, right? Which it is not by default, but if it is, we're going to self.animate whole card, and then that's going to be self.animating card. So then what we're going to do is we're going to deal the flop if we have actually or rather if we have equaled the. So if this becomes equal to self.numplayers times 2, then we need to go ahead and deal the flop, right? So deal flop after whole cards are dealt and animations are done. If self.dealt cards equals the self.numplayers times 2 and not self.animating card, then we're going to go ahead and add an or statement in there, or self.animating card.animation complete. So this is going to be something in our card class, which we have not created just yet. If that evaluates to true, and this is a little bit confusing, but I can basically deal the flop. Self.can deal flop equals true. And then I'll go ahead and just call that self.deal flop function, which does not exist just yet. So then what I'd like to do is check to see if my dealt cards are less than the total number of cards that should be on the table, right? So what I can do is another if statement that comes right after this if statement. If self.dealt cards is less than self.numplayers times 2 plus 3, right? Because there's 3 cards in the flop. Then I also need to check to see that I can deal the flop, and self.can deal flop. Then I can deal the flop. Self.deal flop. Then we're going to print hand data to console. And if not, self.printed flop. So if I haven't already done this, and self.dealt cards equals self.numplayers times 2, and then I believe plus 3, then we can go ahead and self.print hands and self.printed flop equals true. And then lastly, for the update function, we want to evaluate the winner. So I need to check if my self.dealt cards is equal to that number 7. Then we also need to make sure that we have not yet determined a winner. So my final if statement is going to be if self.dealt cards is equal to my self.numplayers times 2 plus 3 flop cards and self.determined winner is none, then this is going to be kind of interesting, but we'll get to that once we get to the algorithm. I'm going to have my eval card set to card id.id for card id and self.players list. And this is going to be index 0, which means player 1, right? And then I need to get their list of cards. So then what I also need to do is I need to add another list, right? And that's going to be the cards that are in the flop. So that's going to be card id.id for card id and self.flop.cards. And I also need to add this again. So this is getting like a ridiculous line here, but I need to add this again, right, because of the way that the algorithm works. And again, we will get to that. But then I need to add, lastly, the player 2's cards, which you can probably guess is just this at index 1. So I'm going to go ahead and copy this for index 1. And that will give us a list that kind of looks like, you know, 10 of spades, ace of diamonds, 7 of clubs, blah, blah, blah. And then it will have the flop cards twice, flop, flop. And then it will have the player, actually, no, I need to get rid of these. 7C and jack of diamonds, right? So this is basically one big list, and we can kind of get rid of this to demonstrate visually. And we're going to input that 10 card list into our determine winner or eval winner function. And this looks a little confusing for now, but it will all make sense in time. And so what I would like to do then is make the value of our self.determined winner equal to self.eval winner eval cards. So then we're going to go ahead and get into the bread and butter of this game, and that of course is the eval winner function. So I did not attempt to create a new version of the ranking algorithm for this game. This has been solved multiple times before. Now, if you did want to actually try this, I would fully recommend doing so yourself. I actually found this phenomenal thread on Stack Exchange. And so someone was basically coming up with a problem, a coding problem that they have, basically a poker.txt file. And you can see that this is basically the same format that I have decided to use, largely because of this thread. And so the challenge basically wants you to go through and see like how many, basically just determine the winner of each hand, right? So you'd basically iterate through every single line in poker.txt, and then you'd get this here, and then you would split this because this is a 5-card hand, and so is this, and then you would output if player 1 was the winner or player 2 was the winner. So if this is something you want to try and solve yourself, please do so. Do not just copy and paste the answer like I did. But if you are okay with just copying and pasting the ranking algorithm, I would definitely take a look at this. And thank you to Toby Spate for basically solving the entire premise of this video in this single post here. But yeah, so by and large, the eval hands algorithm has already been solved for us, and I'm going to go ahead and implement that now. So eval hands is a large function that exists within the dealer because it should be up to the dealer to determine the winner, right? And so we're going to go ahead and do that now. Hand ranking algorithm, and I will basically say def eval hand self hand. And so as per the post, I think it is very important to keep in mind of which hands are the highest rank, right? And so that, of course, is the straight flush, and then it goes all the way down to a high card. So I'm not going to code this line by line. Again, I basically copy and pasted this with some slight modifications from that Stack Exchange thread. And as such, we're going to go ahead and just paste that in. And I will make sure the indentation is at the right place. So I'm going to go ahead and minimize this just to kind of get some clutter out of our screen. We also notice that there are several other things that we need to do, such as create this function here. And so I will do that now. Okay, so this is a really simple function. I'm going to go ahead and just add a comment here. It says getter for number of dealt cards. And basically the way that we will do that is set our total card count variable to 0 at the start. And then I'm going to iterate through my list of players for player in self.players list. Total card count is going to be plus equal to len of player dot cards. And then I also need to get information for my flop because that counts towards my total card count as well. Total card count plus equals the len of self.flop.cards. And then finally, I'm going to return total card count. And that does it for this. We're going to leverage this several times throughout the actual game. I would also like to print the hand to the console. This is another very simple function. Print to console def print hands. And that will just be for I in range len self.players list. We will print an f string of p I plus 1, right? Because we want to start with p1 and end with p2. And right here, this is going to be a little chaotic, but we're basically going to have a list card.id for card in self.players list at index I, and then their cards. All right, so we're basically just iterating through their cards. And I think I could just do this if I'm not mistaken. But this is what I had in my previous version, so I'll just run with it. And then we also need the same thing for our flop, and we will do that outside of the for loop. Print an f string, we'll just call that fl, and then we'll have a similar card.id for card in self.flop.cards. And that is it for print hands. So this, unfortunately, will not run because we still have so much stuff. Actually, I want to see what would happen. I think the big issue is that we don't have a player class, and there's just a bunch of stuff missing here. So yeah, this will just fail miserably if we try to run it. So what I would like to do is start building out these other classes, the player and the flop, and I'm not actually going to do that in the hand.py file. I don't think it really makes sense to do it there. I think it makes more sense to do that in the cards.py file. So we're actually just going to go ahead and build that out completely right now. So a card is actually going to be a class as well that has a bunch of details about it, such as a unique ID, a position, a start position, an original position, which is essentially the start position. And then, we're going to modify a bunch of these details and then basically animate them using a lot of this data, right? We're also going to need image files for each card, which is going to be something that we leverage itch.io for, because I am not an artist by any means. But we're going to start with from collections, import named tuple. And that's essentially going to be what our card is a named tuple. From settings, import asterisk, and import Pygame and random. So we're going to create a card tuple, which is going to be a named tuple. And we're basically going to have that be a card, and then a value, and a suit. And that is going to be how we designate the data. Like we'll have a jack, which will have a value of 11, and a suit will be clubs, for example. And I also need to create a card values list that we can basically use to build our deck at the beginning of the init function in our dealer. And I do want to make sure it's our dealer. Yes, our dealer is the one that has the deck. So we're going to go ahead and card values equals 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's see, 10. Actually, I will print this on a different line to make things a little bit nicer. I'll have our T, our J, our Q for queen, and K for king, and finally A for ace. So we obviously know what these things are, but 10, jack, queen, king, ace. All right. And so now what I can do is actually have a list of suits as well. Card suits equals C, D, H, and S for clubs, diamonds, hearts, and spades. And now it's time to build our card class card. And in our init function, we're going to take in a few parameters. First the self, of course, input value and input suit. And so those will help us actually have our data for the card. And yeah, so we'll go ahead and start with our animation start time, which basically means that as soon as this card is created, we will get this value because we're going to start animating it immediately. Self.animation start time will be set to pygame.time.getTicks. We're also going to have a self.animation complete set to false. We're going to have a UUID or a unique identifier for this. Self UUID equals none. That will be none at first. Self.position will be equal to none. We will then have a start position, self.start position, and that will be equal to where the dealer is going to exist, which we could use a named variable for this in settings.py, but for now I'm just going to put 0, 1080 because that's essentially the bottom left-hand corner of the screen, and that will be kind of where the dealer is, the invisible dealer is sitting, so to speak. And then we're just going to create something called original position that is basically the value that we start at. Self.orig position will be equal to self.start position. So then we're going to create self.data, and that's just going to be a card tuple. And here we're going to have our value is equal to input value. And our suit is going to be equal to input suit. And again, that goes back up to here. These are required parameters for our card tuple. I'm going to basically have our self.id equal to an f string. That's going to be self.data.value and self.data.suit. So think of this as like a shorthand. So if we get a jack of spades, it will be a JS, for example. So now we start talking about files, and you might be wondering, okay, well, what files are we talking about? We haven't actually shown any cards or anything. So I have actually downloaded a series of files into the graphics cards directory. And these are some nice pixelated cards, as you can see here. You can kind of scroll in, and they are from itch.io. And if you're not familiar with itch.io, that is basically a place where you can get game assets, and the user Zix on itch has been kind enough to release this really nice pixelated set of cards. So thank you to that individual, and I will link this in the description of the video as well. And yeah, rather than me trying to create my own cards that would inevitably look horrible, I have simply downloaded them and added them into this directory. There were a couple of changes that I needed to make. I believe that like the face cards all had their numerical value rather than the letter value, and basically for the code that I wrote, it was easier to just have their actual, like if it's a king, K instead of a 13, for example. So I have renamed them accordingly, and you can reference this if you need to do the same thing. But I have basically decided that our self.image will now equal an f string graphics cards self.id.png. And again, with our jack of spades, this would basically end up being graphics cards js.png. And we just saw that the js.png is the jack of spades image that we got from Zix on itch.io. So then I would like to have a random rotation angle similar to what I did with the text of the winner, right, which we haven't actually seen yet, but I'm going to go ahead and rotate our cards randomly as well so they're not in the same kind of angle / position every single time. Self.card rotation angle will be set to random.uniform -3, 3. Cool. So then I'm going to do a few more things, and this is related to how Pygame treats images, right? And it is a bit rough to type this all out if you've ever dealt with images and surfaces and stuff like that. In Pygame, you understand that doing it kind of line by line is a bit painful. So I'm going to copy and paste that, and we're just going to talk about what's going on. Yeah. So we're going to load the image that we have basically stored the path to right here, self.image. That's what I'm doing on this one. I'm then going to re-declare that, or the value of that card.image, basically to transform it to 4 times its size, right? So I'm going to get the width and the height, and then I'm going to multiply each of those by 4, and we're going to get a much larger card. Because if you saw, the resolution of those images is rather low. Then we're going to rotate the transformed image, basically by the rotation angle that we get here, which again is random. Then I'm going to get our bounding rectangle of the now rotated image, and then I'm going to create a surface based on that. And lastly, what I need to do is calculate the position to blit the rotated image onto the surface. And I can just do that with 0, 0. So blit pos will just be equal to 0, 0. And this is kind of, it's not necessarily that useful, but self.card surf.blit, self.card rotation, and blit position. And then actually one more thing, we do want to get a random Y value for our card. And this is so they're not drawn to the same kind of height on the actual board as well, right? This will make it a little bit more varied and interesting. This is a difficult line to type out manually, so I'm just going to paste it and talk about what that is. So again, going back to our position, which is in settings, P1, C1, we're essentially starting with the index 1, which is our height divided by 2. So that's 1080 divided by 2, or 540. And then we're basically subtracting the height, 540 minus whatever the height is, floor value divided by 2. And then that's essentially putting us like in the middle of the screen. And then adding a random kind of padding, if you will, between -20 and 20, which is just a random int there, as you can see. And that does it for the card class. I know that's quite a bit, but this is a very important class, and you'll kind of see how everything works once we start getting everything else built out as well. We're going to have 2 very simple classes that largely I don't even think need to be classes, due to the way that we basically got everything that we need in the dealer class and the card class, but I'm going to do a class player, and that's just going to be our init function with the self input, and self.cards will be the only thing that we create there, and that's just going to be an empty list. And I can do the exact same thing for the flop, and those are 2 very simple classes, but I think that is enough for us on cards.py, so that's good news. So I don't think this is going to work, and it didn't, and that's because we don't have a bunch of the functions that we are calling in the hand.py file, right? So we basically need to go through and we need to make sure that everything is built out as it should be. The first is generate deck. That still does not actually exist. So I'm going to go ahead and create that within the, actually, I'm going to do that within the dealer class. And I'm going to do that up at the top. So I'm going to have a empty list called fresh deck. And then I'm going to have a for CB in card values and for CS in card suits. You see what I did there? Fresh deck.append card CV and CS. And so that's basically a nested for loop that's going to give us a total of the number of card values times the number of card suits, and they basically will all be unique to the total number of 52. And then I can just return fresh deck. And that is going to be what we use when we basically instantiate the dealer object, right, at the beginning of the game. So as you can see, the next thing that we have that is missing is cooldowns. And I can basically go through this and remember every single thing that needs to be built out. That's kind of painful. But yeah, after generate deck, which I can go ahead and minimize, I'm going to minimize everything that I'm not actively working on. After generate deck, I can basically have my cooldowns, def cooldowns. And I'm going to have a variety of things here. I am always going to get the current time every time that I run the cooldowns function, right? And that is just pygame.time.getTicks, and that will get the current time every single time that this runs. And what I'd like to do here is basically have my animation length of time as 200 milliseconds. So if self.last_dealt_card_time and current time minus 200 are greater than my self.last_dealt_card_time, right? So that basically means this has a value, which means I've dealt a card, and then I also have elapsed 200 milliseconds. Then what I'm going to go ahead and do is make it so I can deal again. Self.canDeal equals true. So I haven't actually set canDeal to false just yet. That will be in one of the deal card functions. Then I'm going to have another if statement, if self.last_dealt_flop_time. As you can see, this is somewhat similar. And then I'm going to put this on a new line. Current time minus random.rand int 120, 200. So I kind of want to have a staggered flop that's not like the same amount of time every time. Greater than self.last_dealt_flop_time. Then I'm going to go back and reset my self.canDeal flop boolean to true. And of course this needs to be... There we go, that looks better. And I'll go ahead and run this and see what happens. So I have no function deal whole cards. So we're basically looking to see if I have not dealt enough cards, and then if I have and I can deal, then deal a whole card, which again, it's going to start at player 1. And then it's going to deal the first card. Then it's going to move to player 2, deal the second card, so on and so forth until the number of players times 2, which in this case is 4, is the number of cards that have been dealt. So I need to go ahead and create that function. And this is going to be another hefty function, but I think it is important that we go through it. So I'm going to go ahead and minimize cooldowns. And I'm actually going to create a blank function here, def animate whole cards self card. And I'll just put pass here, but this kind of works in tandem with the deal whole cards function. So we're going to go ahead and create that def deal whole cards, and that takes in self as an input parameter. And of course I need to check if I can deal, if self.canDeal. And then I would like to deal card to current player's hand. And basically the way that I would get that is the current player variable that I would create here, and that will just be current_player equals self.players list self.current_player_index. And then I'm also going to get their cards, and I'm going to append the last index of our deck. In this case, this is the 52nd card, current player.cards.append self.deck at the last index here. Okay, now this is possibly the worst part of this entire project, and that is because it is very much hard-coded where each card is going to go. I'm going to copy and paste this because it is pretty rough, but we're going to walk through it, of course. And yeah, I'm going to do that now. And we'll make sure that we're indented properly. So, again, this is very much hard coding the positions of where each card is going to go. So if my player index is 0, I am at player 1, right? And then that basically means if I have one card, then I'm going to deal that card to this position, which means that I need to actually set the position. And that goes back to the settings file, P1C10 for the X value, and then my randomly generated card Y value. And I basically do that for player 1, and then I do it for player 2, card 1, and then I do it for player 1, card 2, and player 2, card 2. I know that this could be cleaned up and needs to be cleaned up for when I have more players, but for now, for this proof of concept, it will suffice. So we're going to go back to, and actually this is still part of self.can deal, so I need to indent that to this level. So basically here, if self.animating card, self.last dealt card time is going to be equal to pygame.time.get ticks. And that means we are actually setting a value. As soon as we set a value to animating card, then we're going to go ahead and get the timestamp and then self.animate whole card, self.animating card. And we're getting close to this function being complete. I also would like to, let's see, so outside of this block all the way back to here, I believe it is. So for every single one, we're going to go ahead and play audio, which is just going to be self.card audio, and this function is not built out just yet. We also need to, actually we're done with comments there. We also need to make sure we're at the same indentation level. We are, and then I'm going to go ahead and remove dealt card from deck. Change player index prompt dealer cooldown. And that's just going to look like self.deck.pop last index, because we just dealt the last index, which means it's no longer in the deck. And then I'm going to basically add to the current index of the player. And self.current player index is just going to be equal to self.current player index plus 1. And then we're going to do some modulus here on the self.num players, which is largely unnecessary in our example. But finally, we're going to do self.can deal set to false, which will prompt our cooldown, which runs every single frame. And that should be it for our deal whole cards function. And this actually does not need an S. So while we're talking about whole cards, we may as well animate them as well. And I'm going to go ahead and jump right into that process. And we want to get our current time, similar to what we did in cooldowns, and that's going to be pygame.time.get ticks. And we're also going to have our elapsed time equal to elapsed time equals current time minus self.last dealt card time. And this is going to be how we tell how long to animate our cards. So we're going to want to have our current card equal to card, which is an input here. And then our animation duration is going to be equal to 200 milliseconds. What we would like to do is check to see if our elapsed time is less than animation duration. And if it is, we want to calculate the increment for each frame to move the card and update position. And I actually leveraged ChatGPT for this because I'm not great at math, and because of that, I'm just going to kind of copy and paste it, and we'll talk about what's going on. But basically what we're doing is getting some coordinates, right? And so our X coordinate and our Y coordinate origin are going to be from our current card original position. And then what we're going to do is see where they're going to actually end up at, and that's going to be from x, y, set to current card dot position. So then what we're going to have is kind of figure out our animation duration, which needs to be up here, duration. We basically need to keep this ratio that's going, which basically helps us determine the actual distance between where we start and where we finish, and then we will kind of update the coordinates based on that, which we're actually using start position for that, which is a little bit confusing. Probably should rename start position, but in any case, it works just fine this way. And that actually does it for the animate whole cards function. At this point in time, we still have not figured out how to determine the winner. We also have not done anything for drawing of the cards at all, and so they simply do not get displayed on the screen until we create our render cards function. So I'm going to go ahead and do that now. This is actually relatively simple. For player in self.player.list, and then we're also going to have for card in player.cards, self.display surface.blit, card.cardsurf, and the card.start position. It's basically going to be where the drawing starts, and since we're updating start position as part of our animation, every time this gets called, it will get the updated position and thus continuously draw to the surface, and this will look as if it is animated. But I also need to do the same for our flop, so we'll go back here for card in self.flop.cards, self.display surface.blit, card.cardsurf, and card.position, which again is pretty much the exact same thing. But we do not actually animate the flop cards in this example. I basically just have them drawn to the screen in a staggered manner. Again, there is that cooldown timer for can deal flop card or whatever it was. But yeah, we're not doing any animation there. We could if we wanted to, but I did not for this demo. So at that point, we're done with render cards, and we need to render the winner. This one is kind of ugly, but I'm going to go through it anyway. We basically want to have if self.dealer.determined winner is not none, right? And then at that point, we're going to get our text. And the way that we do that is figure out which determined winner it was, right? Was it player 1, was it player 2, or was it a tie? So if self.dealer.determined winner equals player 1, right? Then what I'm going to do is have our text be player 1 wins. And then I also want to have a text color set to 115, 235, and 0, which is it's kind of like a light blue color. Then I'm going to have an elif self.dealer.determined winner is set to player 2. Text will be player 2 wins. And then our text color will be equal to 135, 206, 235, which is a green color. And in the extremely rare case, elif self.dealer.determined winner equals tie, text will be equal to split pot. And then text color will be equal to 255, 192, 203. And that's kind of like a pink color. So I'm then going to have a coordinate value for where I want to print the winner text, right? And that's just going to be coordinates equals 520, 100, and this could probably have a better variable name. But then I'm going to have my winner text, and this I'm actually just going to copy and paste in because, again, it uses the surface, rectangle, all that stuff, and it's just kind of a pain to type. So I'm going to paste that in here, and we'll go over it. I'm then going to create a new text surface using the font that we have input, and then it's going to take in the text that we have just created, which is based on which player won, right? That's going to be text. Then I'm going to have my text color also set to whichever text color we set. Then we're going to create a rectangle based on that with the getRect function that belongs to surface in Pygame. And then I'm going to draw that to the top left, being our coordinates value. I'm going to rotate that to our rotation angle, which is generated at random as part of the init function of, I believe, I can't remember if it's dealer or hand. I believe it might be hand. Actually, is it? Yeah, it is hand. Okay. And then we'll go ahead and rotate the rectangle the same way. And finally, we will blit that to the screen. So now I have my render winner function, render cards function, and I believe our update function. And at this time, we can call the hand class completely done, which is great news. So we have a function to deal our whole cards, which again are the first 2 cards that each player gets, but we're not actually dealing a flop yet, which is a big problem in the game of poker. You definitely want a flop unless the betting ends, and of course there's no betting in this actual demo, but there will be eventually, so we do need to have a def deal flop. And basically what I'm going to do there is set flop card locations. And this is another one of those locations one that is kind of based on where we are in terms of the player list. And again, this is kind of like a lot of repeated code, and I don't really see a whole lot of value in typing this out line by line. So I am going to paste it. But in typical fashion, we will go through that. So we're going to get the X value for our flop by basically looking at our players list index 0, which in this case is player 1. And then we're going to look at the first card there. And the reason I'm doing this is because I want to get the surface's width of the card, right? And so then what I want to do is see which card I'm about to flop. And in this case, this will be the first card, right, if index is 0. And then what I'm going to do is basically say the location for the X value should be basically where 2 of my cards' width would be, right? So I print 2 cards, and then that is where the first X value for my flop should be. So this is going to be kind of like on the right-hand side of player 1's cards. Then we're basically just going to add a little bit of that with some padding for flop card number 2 and flop card number 3, and that's basically what you see here. And at this point, what we can do is 3 flop cards in above set locations, remove from deck, and then of course we have a flop cooldown. So if self.canDeal and self.canDeal flop and self.delt cards minus self.num players times 2 are less than 3. So this is a little bit confusing, but let's say I've dealt 5 cards. Then I subtract 4, my value is 1, right? Which is less than 3, which means I can deal another flop card. We will make a call to self.cardAudio, which is not defined yet. I will also self.flopcards.append the last index of the deck. And then I'm going to change the flop index position to that Y value that is in the actual card. Then I'm going to pop that last index from the deck, self.deck.pop last index. Then I'm going to self.lastDelt flop time is going to be pygame.time.getTicks. Self.canDeal flop will then be set to false and thus kick off our cooldown. And finally, self.current flop index plus equals 1. So I'm going to paste this in even though it's commented out. If there's ever a time where you don't trust the fact that you're getting rid of enough cards, then it might make sense to print out what is left in the deck, right? And the way that you can do that is by printing the length of the deck after a card is dealt. And you can do that with this F string here, which is basically just the length of self.deck, cards left in deck, and then you can get the update card count to see how many are dealt. And basically 52 minus this number should equal this number. And if so, you're good. Probably. maybe. But that should do it for deal flop. So we also need to evaluate who actually wins the hand, and so that requires a function called eval winner. Eval winner is going to take himself and hand to eval, and basically we're going to have our eval cards set to our value dict from settings at, and then we're basically going to have x at index 0 and x at index 1 for x in hand to eval. And that is going to get the actual numerical value, which is going to help us basically run against our eval hand function. And we're going to have a few if statements to basically determine the winner. If self.eval hand eval cards up to index 5. Again, remember we're basically splitting a 10 card list here. So up to index 5 is greater than self.eval hand eval cards from index 5 to the end of the list, right? If that is the case, then we're going to print P1 win and then print their cards, which will basically be the output of our eval hand function. And we're also going to return player 1 for use with our text surface that we had in our render winner function. We're then going to have an elif self.eval hand eval cards up to index 5 less than self.eval hand eval cards 5 until the end. And in that case, I am going to print this f string, P2 win, with P2's hand. And then I'm also going to return player 2. And then finally, I'm going to have an else statement, else print split. Because in that case, it is a split pot. And I will just return tie. Okay, so I know that was a lot, and with any luck, we should be able to run this, even though there's no audio just yet. We might actually have an issue because of that, but I'm going to go ahead and give this a shot. Okay, so I do have a bug here, and it looks like I need to indent this. And my indentation is all messed up because of copying and pasting and stuff like that, so I do apologize. This needs to be indented at the same level after this if self can deal, because it is still contingent on the fact that it can deal. So we'll try that again. And there you go. So this is actually working as intended. You do see there's some overlap on these cards, but we can tell in the console, and I'll go ahead and slide this down and slide this here, basically the cards that are being printed. And so in this case, we have a player 1 with a 9 of diamonds and a 2 of spades, which is correct, a 9 of diamonds and a 2 of spades. And we also have a player 2 with 7 diamonds, which you can see, and a 5 of clubs. And the reason the player 2 wins is because of the result of eval hands, which gives us a pair of 5s. And that is essentially enough. So the rank of this hand is a 1, the pair is a 5, and the total hand is an 11, 7, 5, 5, 2. So we can run this several times, and eventually we'll see some interesting hands, most likely, with a little bit of luck. And actually, let me adjust this so we can keep referencing. There we go. So I'm going to cover that, and we're just going to test this a couple times. So we have a 10 of hearts and a king of spades. Player 1 wins with 2 pairs. So there's a pair of jacks on the board, and then there's a king, so essentially they have 2 pairs. And you can see what that hand looks like there. And it will probably be tough to come up with a split pot, but it does happen every once in a while. It is, and I'm sure I could actually determine the probability of that, but it is pretty rare. So I'm just going to give this like 10 hands and see if we see a split pot. But so far the hands are looking good. They are seeming to make sense. We got a jack and a 6. This is actually a flush in this case, so you can see it as a rank of 5. And the interesting thing about this is you can kind of see that a lot of these are like rank 1, rank 0. So the one thing that I've noticed, it's actually a lot less common to get a good hand than you might think. So unfortunately we did not see any split pots. I'm not going to sit here for a million years generating this. What I would like to do is end by adding some audio, and we can do that very simply by adding our card audio function here. And so we're going to basically have a random wave, which is going to be a random.choice from our wave files list. We're then going to have a wave file path, and that's just going to be os.path.join game audio dir and random wave. And then we're going to assign that, what is going on? I'm going to assign that to a sound variable, and that's going to be pygame.mixer.sound wave file path. And then I'm going to basically have a audio channel, which again we set to 0, as you can see here. And that's where I'm going to play this. So channels self.audio channel.play sound. And finally, we're going to increment that audio channel, self.audio channel plus equals 1. And you can see this channels thing is missing, and what I actually wanted to do is add our audio placeholder stuff here, and I can go ahead and minimize this because we're done with it. And we'll go ahead and fill that out. I'm actually just going to paste this in because it's one of those Pygame things. It's just super annoying to type, but I will walk through it. So we're basically initializing the Pygame mixer. I'm then getting a list of audio files, and we'll take a look at that really quickly. Very similar to my cards. We can go into the audio directory, and you see that there is this list of wave files. And so I also got this from a different site. I basically searched on Pygame for card dealing sound effects, and then I found this one right here, playing cards being dealt. And as you can see by looking at the wave, it's basically just dealing cards over and over and over again. And I split this up, basically every time a card is being dealt, I split this up with Audacity and saved it as a new wave file. And that is what you see here. Feel free to do the exact same thing. This will be linked in the description of the video, of course. And yeah, so then at that point, we basically get a list of all of the files in that directory. We create a number of channels that's equal to the length of that list. And then basically I set my number of channels based on this number of channels within the Pygame mixer. And then finally we have that here as this channels list. So at that point, with a little bit of luck, we should be able to launch this and get some dealing card audio. And we got nothing, and that is because I forgot to uncomment something, if I were to guess. And it's probably in deal whole cards. And this does need to be indented as well. Alright, let's give that a shot again. And there we go. So this is super basic audio. Obviously you could get a little bit more advanced if you wanted to, but for the premise of this video, that is completely sufficient. We're going to go ahead and use this to build out a higher player count poker game that's going to be more dynamic, that can potentially have players get up and leave the game. And maybe if we get to it, slash if I am good enough of a programmer, I'm going to go ahead and add some logic to determine betting and whether or not the computer would bet against you in a given scenario. So if you made it this far, thank you so much for watching. If you have any comments or questions like that, please leave them and I will do my best to get back to them. And I will see you in the next one.